Welcome to today's lesson on comparing and ordering a set of real numbers. Your due now is to answer this question. Alyssa will correctly label the numbers 48.4, 48.5, 48.09, and 48 and 3/5 on the number line. Which number will be located closest to 49? We have A is 48.4, B is 48.5, C is 48.09, and D is 48 and 3/5. The first way to solve this problem is to identify where each number would be on the number line. And to do that, we're going to have to convert all of the numbers that are not in decimal form to decimals. So that'd be answer choice B. Instead of 48.5, it would be 48.5. And then answer choice D, instead of 48 and 3/5, it would be 48.6. So we can write all these numbers on the number line, but if we know that the number has to be closest to 49, we know that we're looking for the biggest number. So 48.4 is smaller than 48.5, and 48.09 is smaller than both 48.4 and 48.5. So that means that the correct answer choice is D, 48 and 3/5. Today's TEK is 8.2D. Our lesson target is that scholars will compare and order a set of real numbers from math and real-world contexts. Your DOL is given 4 problems. Scholars will compare and order a set of real numbers from math and real-world contexts with 100% accuracy. So we have this question: name a number that is between 2 and 1/4 and 2.5. Represent your number more than one way. And so that's what this expression says. It's x is less than 2.5, and then it has 2 and 1/4 is less than x, but another way to write that would be x is greater than 2 and 1/4. So as you can see, we flipped the symbol once we flipped the order of the x and the real number. And so we're looking for a number between 2 and 1/4 and 2.5. So I know that 2 and 1/4 is the same thing as 2.25, and I found that out by dividing 1 and 4. So 1 divided by 4 is 0.25, and then I have to add the whole number 2. Then we have 2.5 is the same thing as 2.5. So we're looking for a number in between 2.25 and 2.5. So a number that I can think of off the top of my head is 2 and 1/3. And because we have to represent that in more than one way, so the decimal form of that would be 2 and 3. And just to shorten that, I can just write a line on top of the 3 to show that that number is repeating. Another number in between 2.25 and 2.5 is 2 and 2/5. As a decimal, it would be 2.4. All we had to do was divide the 2 and the 5 to get 0.4, and then you have to add the whole number of 2 in front. We now have to name a number that is between pi and square root of 15, and we have to represent our number more than one way. So pi is around 3.14, and then we have to figure out what the value of square root of 15 is. So we can estimate its value by finding the nearest perfect squares, or we can just use a calculator. And so the square root of 15 is about 3.87. So we're looking for a number in between 3.14 and 3.87. One such number is going to be 3 and 1/4, which as a decimal is 3.25. Another such number is going to be 3.5, which as a decimal is 3.5. And we can even do 3 and 3/4, which as a decimal is 3.75. So some academic vocabulary that is going to be useful for today's lesson is real number, which within real numbers are rational and irrational numbers, and perfect squares are considered rational numbers. Perfect squares are the squares of whole numbers. So for example, we have 1 square, which is 1, 3 square, which is 9. So perfect squares are these solutions when you square or you raise a number to the power of 2. Principal square root is only the positive number square root. So if we have square root of 144, when we think of what number times itself makes 144, our answer is 12. But with square roots, answers can be both positive or negative because positive 12 times positive 12 makes 144, but negative 12 times negative 4 also makes positive 144. For this first IG problem, we have to compare. We have to write less than, greater than, or equal to this expression, to this expression. So we have square root of 2 plus 4, and then 2 plus square root of 4. So step 1 is to find the closest perfect squares. So we have square root of 2 is in between square root of 1 and square root of 4. So square root of 2 must be between 1 and 2. And find the square of the number in between. So 1.5 is halfway between 1 and 2. And 1.5 squared, which is the same thing as 1.5 times 1.5, 2.25. And since we're trying to, we know that the square root of 2.25 would be 1.5. So we know that square root of 2 has to be a little less than 1.5. So let's just say it's 1.4. And then if we check on the Desmos calculator, we'll see that it is about 1.4. So we have 1.4 plus 4, which makes 5.4. So that means that the first equation is equal to 5.4. Then we have to figure out what the square root of 4 is. So that's a perfect square. So 2 times 2 makes 4. So the square root of 4 is 2. So now we have 2 plus 2, which is equal to 4. And so we're comparing 5.4 and 4. We know that 5.4 is greater than 4. So that means that the greater than symbol is going to go in between the two equations. So we're doing the same thing for this we do problem. We have square root of 12 plus 6, and we're comparing that to 12 plus square root of 6. So we have to find the closest perfect squares to the square root of 12, as well as the square root of 6. But we're going to start with the square root of 12. So square root of 12 is between, that's my shorthand, b slash t is my shorthand for the word between square root of 9 and square root of 16. And square root of 9 is equal to 3. Square root of 16 is equal to 4. So we know that the value of square root of 12 is between 3 and 4. And then we have to figure out the number that's halfway in between 3 and 4. So I'm going to say 3.5 is halfway in between 3 and 4. And so we're going to square the number that's halfway in between. So 3.5 squared, which is the same thing as 3.5 times 3.5, is 12.25. And we're trying to find the square root of 12. 12.25 is a little bit bigger than 12. So we're going to guesstimate that the square root of 12 is about 3.4. And then for 3.6, 3.6 is between square root of 4 and square root of 9. So that means that square root of 6 is between 2 and 3. And a number that's between 2 and 3 is 2.5. So we have 2.5 squared. 2.5 times 2.5 is going to be 6.25. If we're estimating or approximating the value of square root of 6, we know that if we square rooted 6.25, we'd get 2.5. So the square root of 6 is going to be about 2.4. So from here, we have the square root of 12 plus 6, and we estimated that the square root of 12 is around 3.4, so we have 3.4 plus 6 is equal to 9.4. Then we have 12 plus square root of 6. So then we have to solve for that. The square root of 6 we estimated was around 2.4, so we have 12 plus 2.4, which is around 14.4. So now we're comparing 9.4 and 14.4. 9.4 is less than 14.4. So we're going to put the less than symbol in between the two equations. This next I do problem reads order the set of numbers from least to greatest, then graph them on the number line. So first we're ordering the numbers and then we have to graph them. So step 1, turn all real numbers into decimals. So we have square root of 6, negative 1.25, 150%, and 2.45 with the lines on top. So that means that the 4 and the 5 are repeating. So the square root of 6, if we use our Desmos calculator, is around 2.4. Negative 1.25 is already in decimal form. We have to convert 150% to decimal form. So all we're doing is moving our decimal point, which is at the end of the 150, 2 places to the left. So it becomes 1.50. And then 2.45 was already in a decimal. Step 2 is we're going to order the decimals. So the smallest number is going to be the negative number. So we have negative 1.25. And then the next smallest number is 1.50. The following number is going to be 2.4. And finally, the last number, the biggest number, is going to be 2.45. Step 3 is to order the real numbers from the decimals. So we've already ordered the decimals, and so now we have to make sure that we're writing it back to its original form. So negative 1.25 was the representation of the number in its original form, so we're going to keep that. Then we have 1.50, which in its original form was 150%. So we have to change it back. Then we have 2.4, which in its original form in this problem was square root of 6. And lastly, we have 2.45. So we answered the first part of the question where we ordered the numbers from least to greatest. Then we have to graph them. So we can do that because we have the numbers in decimal form. So we have negative 1, 0, 1, 2, 3. Negative 1.25 is around here. So this green dot represents negative 1.25. Then 1.5 is in between the 1 and the 2, and it's represented by this red dot. Then 2.4, if this right here is 2.5, 2.4 is going to be this blue dot, and then 2.45, which is a little bit after, is this pink dot. This we do problem, again, we're ordering the set of numbers from least to greatest, and then we have to graph them on the number line. So our first step is to turn all the real numbers into decimals. So the square root of 12 is going to be 3.4. Pi is about 3.14. Then we have 3.46. And the line on top means that the 4, 6 are repeating. Then we have 11 over 5. So we're just going to divide 11 divided by 5 to get our decimal form, which is 2.2. Step 2 is to order the decimals. So the smallest number here is 2.2. And so we're keeping them still in decimal form. Then the next smallest number is 3.14. Following that is going to be 3.4. And then we have 3.46. Our last step is to order the real numbers from the decimals, but turning it back to its original form from the problem. So we have 2.2, which originally was 11 over 5. So that's the form that we're going to return it back to. Then we have 3.14, which originally was pi. 3.4 was originally square root of 12 in this problem. And lastly, 3.46 was in decimal form, so we are just keeping it the same. So now, since we have to graph it on the number line, we're given a blank number line, so we have to figure out what the constraint should be, or what the line should represent. So I'm going to say that this is 0, this is 1, this is 2, this is 3, and this is 4. And so 2.2, which is 11 over 5, is going to be around here. So 11 over 5. Then we have 3.14. This is going to be around here. So that's pi. Then we have 3.4, which we have to write as square root of 12, is going to be around here. And lastly, we have 3.46, which is going to be a little bit afterwards. So in this Nearpod, you have some activities to do. You have to compare using less than, greater than, or equal to, and it was a poll. So we have the square root of 3 plus 2, and then the square root of 3 plus 3. Then we also have the equation square root of 11 plus 15 compared to the square root of 8 plus 15, and it was also another poll. Then we have square root of 6 plus 5 compared to the 6 plus square root of 5. Then we have a question which shows the numbers in order from least to greatest. We have 3.141, 3 2/3, pi, square root of 3, and 3.1. And it was a quiz question. Then there was a fill-in-the-blank activity. And lastly, your DOL. So go ahead and click on the Google form in this slide to access your DOL. So it's 4 questions. Thank you so much for following along in today's math lesson, and see you in our next math video.